For the first two problems on the review for Chapter 9, we are just given the equation of two circles. I know that they're circles because we're adding our x squared and our y squared, and because the coefficients in the front would be equal values here. Remember that if you have anything in parentheses like this over here, that just tells you where the center is going to be at. So to find the center, since we do not have any parentheses around our x and our y here before it was squared like we do on the right side, we have a center at 0, 0 for this first one. And I'll plot the center at 0, 0. The radius is found by square rooting the number on the right side. Square root of 4 is 2, so the radius value is 2. That means we would go 2 to the right of the center, 2 above the center, 2 to the left of the center, and 2 down from the center. And we would create our circle through those points. For the second one, the center is not 0, 0 because of this parenthesis around our x. Remember that when you have these parentheses, you change the sign on whatever you have here. It says x minus 2, so the x value of the center is at 2. The y value of the center is at 0 because there wasn't any parentheses with any weird numbers over here with the y. The radius on this one, 5, when you square root it, you will not get a whole number. If you want to think about what it's close to, 5 is very close to 4. Square root of 4 is 2. The radius is just over 2. I'm going to put the radius as the square root of 5 just to be exact for this part. To plot the center, I'm going to go to the point 2, 0 and make a dot. Now the way that I'm going to count this radius, and you could use your calculator and get a decimal value and use that, but I know that it's just over 2, so I'm going to count over 2 and just a tiny bit more. Up 2 and a tiny bit more. Back 2 and a little bit, and down 2 and a little bit. And this will be for my circle right there. Now, for the third problem, we are having to rewrite this equation. Notice it just sort of looks like a mess right now. We're having to rewrite it into standard form. It's going to look like problem number 2 does, where we have these parentheses and then squaring it. And to get to that point, we know that we're going to have to complete the square because we have x squared and we have x's and we have y squared and we have y's. That's what tells me I will have to complete the square. In order to get this problem ready for completing the square, I need to move any constants to the opposite side, so the 33 will move over and be negative 33. And I also need to group my x's together and group my y's together. Now, one thing that is really nice about this problem is that they do not have a coefficient on our x squared or on our y squared. We also have a positive here, which makes it also easy. So I'm going to group my x's on the right. X squared, this was a positive 14x, so I'll put plus 14x, plus, and I'm going to put a box for my placeholder because something will have to go there, plus my y's, y squared plus 6y plus box for my y's equals, moving the 33 over makes it negative 33. And I'm going to put my 2 boxes over here as well because I need to remember to put those numbers from these boxes on the left have to go on the right as well so that it's equal amounts that we're going to be adding to each side. Remember that we want it to look like something in parentheses squared and then something in parentheses squared with a plus in the middle. We know that this is going to be x and that this is going to be y, and we know we're going to be equal to a number on the right here. So this is my ultimate goal. To get there, I need to factor my x's. So I'm going to factor these here. I'm going to say x, and what you always do is you do half of 14. Half of 14 is a positive 7. So these will both be x plus 7. 7 times 7 is 49. So over here we'll also put 49. Now in this box we're just going to rewrite it as x plus 7 squared. For the y's, I need to do the same thing, 2 sets of parentheses, y and y. Half of positive 6 is positive 3. 3 times 3 is 9. So in this box, we'll put a 9. And in this box, we'll just put the plus 3. Now on the right side, I'm going to simplify all of this together. So negative 33 plus 49 plus 9 is 25. So the center of my circle, because I do have to graph it as well, is at negative 7, 3, or negative 7, negative 3, because you got to change the sign from each of those. And the radius is the square root of 25, so the radius is 5. So I'm going to plot this at negative 7, negative 3 is the center, radius of 5, so count 5 in every way from the center. And this one kind of goes a little bit off of the grid. And then draw your circle. Try to make it look like a circle if you can. Don't make a diamond. That's a pet peeve of mine. The last one on the front page has you writing the standard equation of a circle centered at the origin, meaning that the center is going to be at 0, 0. Whoops. Still got that auto shape pen on. Center is going to be at 0, 0. So I can plot the center at 0, 0. It says that the circle passes through the point 2, 8. So if I plot the point 2, 8, I'm going to go over 2 and up 1, 2, 3, 4, 5, 6, 7, 8 from there. Here's the point 2, 8. And what you can do is you can figure out the radius by drawing in your a right triangle here. This would be the radius, the hypotenuse. And if I know the lengths of the legs, I'm going 2 over and up 8. It's kind of like the slope stair step here. I can use a squared plus b squared equals c squared, Pythagorean theorem, to find the radius length. So 2 squared plus 8 squared equals my radius squared, so that would be 4 and 64. So 68 is the radius squared. Remember that the formula has the radius squared in it, so we do not have to square root that. So centered at the origin means that the first part of this circle equation is just going to be x squared plus y squared, because it doesn't need any parentheses because being at 0, 0, equals to the radius squared 68. And that is the answer for that one.